Hi modelers, it's Chris and we're back with video number 4, Model Railroad Test Track to learn automation with DCC EX and EXRail. So for those of you who would like to try out the coding on the last video, number 3, all you need is a CSB1 and a length of track long enough to run the automation, with a loco running at speed step 25 for about 10 seconds. So for the loco that I'm running, it only needs to have a length of flex track. Okay, so here's a quick overview of the test track wiring, along with the CSB1 and the other components that make up the test track, which is made up of 8 blocks that has a screw-in terminal at the middle of each block, allowing me to test different types of block detection. There's an infrared detector at both ends of the track, a CSB1, 2 OLED displays, a power splitting cable supplying power to the CSB1 and to the power distribution board, which supplies power to the 2 buck converters supplying 3.3 volts and 5 volts. The CSB1 and buck converters both get 15 volts at 4 amps. There's an accessory power bus supplying both 3.3 volts and 5 volts, running the whole length of the test track. The black cable is ground, the white cable is 3.3 volts, and the blue cable is 5 volts. There's an I2C splitter board connected to both the OLED displays and to 2 I/O expander boards and 1 servo controller board. There's a PCF 8575 I/O expander board with 16 pins. It's connected to the DCC 8 block detection board via 8 jumper wires. It also has 2 wires running out to each of the infrared boards at either end of the track. The DTC 8 is connected to each of the blocks via a red wire connected to the terminal block. The way that it works is the red wire is connected to a screw terminal, and then the other side of the screw terminal, a yellow wire comes back and completes the circuit. In between the 2 screw terminals, there's a piece of wire that feeds through the transformer that measures the current draw on the track. That way you know that that block is occupied. Here we have a PCA 9555 I/O expansion board. I'll cover more about this in a future video. The next board is the PCA 9685. It's a pulse width modulation board that controls servos. It can also be used to control the brightness level of LEDs. Here we have 3 wires that are not connected. They will be connected to a servo in a future video. And lastly, we have an 8 relay board. This is used to change the polarity on the electrofrog points that I'm using. Now, as you can see, the test track wiring could represent a small layout, and the wiring could quite quickly become a spaghetti junction, something that you need to avoid. So to do a neater job, you should label both ends of the wire. Now, although I haven't done this on the test track, it wouldn't take a great deal more wiring to turn it into a situation where it'll be a nightmare to try and trace the wire backwards and forwards. Now, if you're new to this, it would be a good idea to build your own test track. It's a cheap way to learn and find out how the various components interact with each other. So let's talk about the CSB1 for a moment. If all you want to do is run a few locomotives manually around your layout and with no automation, then the CSB1 is perfect for that. However, once you start to introduce automation, you need to know things like where the loco is, so block detection comes in, or a particular point on the track where you want it to stop. So even a simple automation like a shuttle backwards and forwards requires a little bit more thought and a few more components, and are connected through I/O pins, and there's only a few spare. That's where I/O expander boards come in very useful. The small board on the left is a PCF 8575. It has 16 pins that could connect to 16 block detectors or 16 infrared detectors, or any combination of sensors you want to connect to the CSP1. Now in your code you have to tell the CSP1 about this sensor by placing this line of code at the top of your My Automation file before any call is made to the pins. This one is a PCA 9685 and it's really for controlling servos, which are mainly used for point movement. You can also control the brightness of LEDs with this board because it's a pulse width modulation board. We'll get into more detail on both of these when we get into the coding. Now looking at the small board again, the PCF 8575, note that in the line of code above, the 200 refers to pin number 200, which would be pin 0 on the board itself. Now let's say that pin was connected to an infrared detector, so as the loco passes by you could stop it, you could increase or decrease the speed steps. In other words, you're at a point on the track and you want it to do something. Okay, now we've finished looking at the test track, let's start looking at some coding. First of all, I've deleted the last automation that we worked on in the last video from the My Automation file. Next, I added a short delay at startup to allow for various components to boot. In the last video, I said that I'd be cutting and pasting, and I'll continue with that because I don't want you to have to sit through one finger typing. So this is the next piece of code that I want to add in. First of all, I've added a reference number to the video that I'm working on. This reference number could be the version of your code. We discussed this earlier when I spoke about the folder system. The next series of lines are a numbering system, so that when I'm looking at the code I can tell whether it's an automation or route or a sequence or a locomotive. So as I said in the past, you need to have a unique number for all of your automations, routes and sequences. This way the automations are going to be in the 1000, the routes are going to be in the 2000, and the sequences are going to be in the 3000. I'll talk more about creating virtual pins later, but they will be in the 4000 range. Okay, let's move over to the My Automation file. Now the first line of code that I want you to pay attention to is quite important. All of the accessory boards that you add will have an address. So this line of code initializes the PCF 8575. This section is the address. This refers to the first pin for this board, and it has 16 pins. So it goes from 200 to 215. So next we're going to add the automation. So as you can see, we've added an automation, but now we're using the numbering system that we've got over in the config file. So this is automation number 1000. We've also changed the title to shuttle with sensors and sound, because in this sequence we're going to be using the sensors to drive the train as opposed to using a timed sequence. So auto start, power on, set the track, and then we go to our first automation. And as before, we'll start the loco, we'll turn the headlight on, we'll delay for 3 seconds, and then we'll call the sequence 3000. In that we will delay for 3 seconds, we'll turn the horn on for 1 second as we did before, and we'll move forward at speed step 25. When we get to block B7, we're going to increase the speed to speed step 60, and then when we get to block 3 we're going to slow down to 25, and then at the infrared sensor on pin 208 we're going to stop. Now we've got momentum turned on, so it won't be a dead stop, it'll give you a nice gentle stop. The same thing will happen when you go from speed step 25 to speed step 60. Then we'll reverse, we'll turn on the bell, we'll reverse at speed step 25. At block B2 we'll increase the speed to speed step 60, and at block 6 we'll decrease the speed to 25, and then we'll see the infrared sensor on pin 209. We'll wait 3 seconds, we'll turn the bell off. Now this sequence will continue to repeat over and over until such time as we stop it. So now let's look at the next couple of automations. The first one again is the same as what we did before, except we're using the same sensors, and that is the shuttle with sensors and no sound. So again we go through the process of turning on the headlight and running the sequence backwards and forwards, stopping, slowing down, speeding up, etc. by when it hits various sensors and blocks. And of course it's automation number 1001 and 3001 for the sequence. So now this sequence will continue to repeat over and over until such time as we stop it. When starting a automation, it's important that you have a starting point, because the automation will run through the instructions in order. So if you were to start with the loco sitting somewhere around this particular point, it hasn't done the things before it, so it might not behave correctly because it's looking for this particular block to happen and you've already gone past that. So it's good to have a process where you can reset. The stop all instruction stops all automations, routes and sequences wherever they are for the whole layout. All your trains will simply stop. The go to a starting point automation simply says reverse at speed step 25, goes to a point where the infrared sensor is, and then it stops. It delays for 4 seconds, then it goes through the shutdown process, which can take about 6 seconds. Now at that point the loco is at a known position, and you can comfortably start the automation knowing that it will follow the process, what you've outlined as far as the instructions are concerned, in order. If you're doing a sequence where you have a loop, then you have to have a starting point, or any sequence for that matter. It can be a simple travel to a certain point, but you have spots along the way that you're testing for what the loco is doing. So traveling through blocks or passing infrared sensors. All those things need to happen in the order of which you've written the code. So that's it for the coding section on video 4. We'll quickly run the loco and demonstrate how these last two automations work. Okay, so now let's have a look at our automations in Engine Driver. So we'll start Engine Driver. We'll choose the server, which of course is the CSB1. Then we'll select a loco. Now I'm selecting from a couple of locos that I have pre-installed. So you can see the loco up the top, and you can drive it from here. But we're going to look at the automations. So we'll go to routes, and there's our automations for this video. Go to a starting point, shuffle with sensors and no sound, and then stop all. So we'll go over to the test track and we'll show you these automations in action. Okay, so we've got our loco on the track, and the first thing we're going to do is get it to a starting point. So it's running backwards, it hits the sensor, it stops. So now we're going to start the sequence with sound and sensors. The loco starts up. And starts going forward. At B7 it speeds up. And at B3 it starts slowing down. And at that infrared sensor it stops. Turns the bell on and waits a few seconds and then reverses. At B2 it starts to speed up, and at B6 it slows down and stops at the infrared sensor. And then it starts the cycle again. Now, if we stop the locomotive it will just instantly stop, and we can head back to the start. We'll go back until it hits the infrared sensor and then go through the shutdown process. So that's it. So that brings us to the end of video 4. So what's next? Well, in video 5, we'll split the automations that we've done into separate files so you can use them from the throttle, as well as making it easier to read when you start doing longer and more complex automations. It's a good idea to split them up into bite-sized pieces, so we'll show you how to do that. We'll also add a roster that will appear in your throttle. So as always, I hope that you've enjoyed the video. Please leave some comments below and subscribe and ring the bell. It'll help grow the channel. And have a wonderful day modelling. All the best. Bye for me. I'm Chris.